Hello everyone. Well, we have a fun evening in store tonight, so I thought, why not take my Model 16 and see if I could get it to exchange data with something that's completely out of its era. So I thought, being a Hadoop engineer myself, or at least that's one of the many things I guess I do, jack of many trades, master of few, but the last few years I've been a Hadoop engineer and doing platform automation with Puppet, mainly to install Hadoop. I figured it might be fun to try and connect the Model 16 to a Hadoop cluster, even if superficially. So in this video, I'm going to show a one-step process for reading and writing from a Hadoop file system, or HDFS, using the Model 16 in a single command. So that's not to say there's not an intermediary, but you don't have to interact with it. It'll be one command on the 16, and files will come and go from HDFS. So this is the Model 16, and we have some files here, nothing major, that's my home directory. And we're going to go over here. So essentially, this is my Hadoop cluster, and this is not a lesson on Hadoop or HDFS. I couldn't go through all of Hadoop and HDFS and teach it in 100 videos, and if I did, I'd charge. So we're just going to go into some basics about how this works at a high level. So this is my Embari management console for my TRS Hadooper. And Hadoop is a large clustered data processing platform for large-scale big data. So it's meant for terabytes and petabytes of information. It can work on all sorts of stuff, relational data, free-form data, whatever you like, but I mean, put it in the hands of an enterprise and all they see is a giant database because they see the relational components. And that's how they use it, so that's the direction the platform's going. And it's kind of sad, but anyway, that's my soapbox. So let's look at this thing a little bit. So here we have the Hadoop file system, or HDFS, and that's the part we're interested in tonight. And basically the Hadoop file system is broken into, well, a few kinds of constructs, but the big two are the name node, which is essentially the librarian of the entire thing. It's like the master file table in NTFS, or the file allocation table in a fat file system. It keeps track of where everything's written. And then you have the data nodes. The data nodes are where the blocks that you write are written to. In the case of HDFS, these blocks are actually just files that sit on a real file system. So HDFS is a pseudo file system. It's not something you mount directly. It's not something that supports updates mid-file or anything like that. It's an append-only file system meant for data to stream in large quantities, or be appended or erased and recreated, what have you. That last one's less than optimal, but people do it. Anyway, so I have 6 data nodes here. A data node is a virtual machine. In my case, it's a host, a computer system running an operating system with its own file systems that stores the data that it is written to HDFS. These are also the nodes that run jobs on that data. So if I submit a job to a cluster and I want to count all the blue Buicks, I can talk, in my data set, these are the nodes that would store the data and do the computation. And these are all virtual machines, so this entire cluster is made up of a total of 9 nodes, 6 data nodes for storing and processing the data, and then 3 what we call management nodes. And the management nodes just run all the Hadoop services. There are also nodes called edge nodes, which are client nodes. In my case, the management nodes are also the edge nodes, and you'll see that in just a moment when I use the Hadoop client. But this is my Hadooper. The HDFS file system that I have has just about a terabyte of space. Each of the data nodes that I've built has its own disk spindle, so even though this isn't meant to be high performance, you won't have thrashing on a single disk because you've got 2 data nodes running. Each data node has its own spindle, and I accomplished that because each of these are running across 3 VMware ESX hosts, and I have a single data store for each of the spinning disks in the server, in the host. So one virtual machine for each data node is associated with a different data store. So that's that. There are other services over here. Yarn, the scheduler for jobs, MapReduce, a key value pair system for basically associating data with key value pairs, and then taking that key value pair data and reducing it down in some way. And that's all in the way that you write it. Hive is relational. For relational data, your typical columnar, third normal form, whatever. Data, Oozy Zookeeper is basically a state machine for the services in the cluster. They give you current state, so the HDFS file system and Yarn and other services use Zookeeper to make sure that they have current state stored in a single place where every component can access it. And we have a message broker and some other things like that. But anyway, that is as far into Hadoop as I'm going. Suffice it to say that this is not a file system you generally mount. You access it through a client application. Oh, one thing I did not go into. I currently have Kerberos enabled, so Hadoop clusters can be secured, and always should be. If you're standing one of these up and you don't, I'm wagging my finger virtually at you. But anyway, this is a Kerberized cluster, so not that it'll matter too much, except that for me to be able to do this, you can see here I've KN'd and I have a Kerberos ticket. I'm running my own Kerberos KDC here. I should also note this is not a work system. This is my own personal Hadoop cluster. I don't use it for big data. Per se, it's on virtual machines because I want to be able to test integration and develop against it and do stupid things like this. So anyway, let's take a look into HDFS. And I do that. In HDFS, I've created a /data directory. And in there, you can see I have a XENIX directory that's world readable. And there's a reason for that that we'll get into later. And there's nothing in there. So how about we put some data in there, and then we'll see if we can get the Model 16 to get it. So here we go. I'm going to echo. This is a file from HDFS, not GS, FS. And I'm going to pipe that to Hadoop fs-put data. Man, I can't type today. XENIX / and we'll just call this hdfs.txt. hdfs.txt. Did I type that right? Echo. This is a file from HDFS. Pipe it to Hadoop fs. Put. Oh, I forgot my little dash there. There we go. I knew I was forgetting something. There we go. Okay, and let's just look at this file. I have Hadoop, and you can see I'm using the Hadoop FS client to do this. HDFS is Java-based and has a Java-based client. You can write your own client. The classes are out there. Okay, we have a file in HDFS. And just for the sake of seeing it there, there she blows. All right, let's bring it down to the Model 16, shall we? Sorry about that. We had a little snafu. There's a cut in there. I apparently fail at typing like 7 times. So anyway, we were looking at the hdfs.txt file. I just put into HDFS, and you'll see that it's not here, but we're going to bring it here. hdfs.txt, and these keys are super sensitive since I redid the keyboard. Okay, so I'm using UUCP. I've given the secret away, and I'm basically using an intermediary here. So what I've got here, and I didn't mention before, is the HDFS file system has a component called the NFS gateway that I've set up that allows you to mount it like a traditional file system. As I mentioned, HDFS is not traditional. And that's running on this Pi here that you've seen in previous videos when I've done my terminal videos for the Handy 1000 or other machines. So here I have a, oh, and you can see the incoming call, handshake successful, and we're sending the file. All right, there she goes. All right, so this is the Pi sending the HDFS file down to the Model 16. Now, this is not a modem. This is a direct serial connection. But I was about to say UUCP is not instant. It's actually, it's batch. It's meant for lines that are not always active, like a dial-up line would have been in the 80s when UUCP was in its heyday. So anyway, the machine queues up all the requests, and then it goes and dials into the systems, downloads or uploads the files, and then finishes. So in this case, the Model 16 has dialed into the Pi, which again is right here and connected to its serial port. And now we should have an HDFS file. Hey, look, we do. Let's cat that, shall we? The keyboard gets better as I use it. But anyway, okay, so this is a file from HDFS. So it wasn't here before. It is here now. UUCP for the win. Okay, if you've seen my previous videos, you know I created a text file about a VI and basically the familiarity of it. When I first installed the XENIX system, I created a little XENIX demo and put this on there. And I added yo at the end because why not say, you know, put a greeting at the end of more to come. But anyway, let's put this up onto HDFS. So before we do, let's take a look and see that it is not on HDFS. And here we go. And it is not. So let's put it onto HDFS, shall we? And I'm sorry for all the spinning. Whiskey. Classic computers, classic whiskey. It's a winning combination. I didn't drink that much. Anyway. Let's put this up there. XENIX. Oops. HELLO.text. And we're going to go back to the Pi. HDFS. Data. XENIX. I should have made this path shorter, but hey, that's what I get. HELLO.texts. Okay, so XENIX hello, Pi, HDFS data, XENIX hello.text. Let's go back and watch this. Okay, so we don't have it yet, but as you can see from the log, we're still waiting for our incoming call. And the machine will momentarily, quote, dial in to the Pi. And this is just, on this machine, this is just an SSH terminal into my Pi. This machine is nothing but my demo machine. It doesn't actually run any of this. And here comes my incoming call on TTY USB 0. We handshake, we got the file, and the call is complete. So now if I go back to my HDFS window and list the files again, there it is. And let's cat that file. And since I don't feel like typing that entire thing, and just for the sake of posterity, Mbari has what's called Mbari views, and I can use the files view to look at this. So, data, XENIX. Hey, look, there it is. XENIX hello.text. Can I open it? There it is. There it is. Straight from the Model 16 to an Mbari views near you. So there we have it. We have a Hadoop cluster running on 3 different ESX machines with a Hadoop HDFS pseudo file system and the ability to put a file up from the Model 16. And just because it's so much fun, let's do one more. If I could type more time. Okay, and let's put that up. And when we're done with this, I will show you quickly what's happening in all of this. I know this video is a little longer. Oh, okay, good, I got that. This one's a little longer than my usual videos, but if you're interested, you're still watching, and if you're not, you were done about 6 minutes ago, so whatever. Okay, and we have, obviously we don't have it yet. Nope, that's not the one I wanted. But let's wait for the Model 16 to call it in. Here it comes. There we go. And again. And you know what? We'll just look at it in views this time. Okay, there's time. I clicked away kind of quick, sorry about that, but you'll see it again in the file list here. And we have data and XENIX and time, just like the Pink Floyd song. One more time. Okay, so how exactly does this work? Well, UUCP, I'm not going to get into the whole lesson of UUCP, but I will just kind of show some of it. UUCP. So on this side, we have, the file set to configure UUCP. The big one here, there's one for the ports, the big one being sys. UUCP is based on the fact that you've configured both systems to know about each other independently. There's no handshake for unknown clients. I mean, theoretically there is later on, but in this iteration there's not. UUCP also is used for sending mail and news and doing remote command execution on machines, but it was really designed for the time when machines might be locally connected or even connected here and there based on dial-up connections, so batch remote. But anyway, here, so I have my TND16 system. The login and password are stored in another file, which I will not be showing you, and then the ACU port. And so an interesting thing about that, you can see here for the port, ACU is just a direct port. I have the dialer line commented out because there's no dialer, it's direct. The device, that's the USB serial port, and speed 9600. Now you'll see it's a little different over on the Model 16. Let me just, I know you can't see that, but not that the password on this thing is mega secure, but let's look in user lib UUCP. LS. Okay, I should have done LC. Why did I do LC? Alright, so here we have a bunch of information, files containing dial information, the UUCP commands. The other things that are interesting, L.CMDS is actually incoming commands if the other machine was to dial this one, that it would be allowed to run. We're not doing that, I'm doing one way. So let's look at L-devices. And what I had to do with this was I had to run disable TTY 01, because that's what I'm running on, and you can see this file just has dir as direct. We do more L-devices. Okay, that way you can actually see it. So the ACUs are callouts on a modem. And then we have direct TTY01, 110 baud, 1200, 150, 2400, 300, blah, blah, blah. Quit. Okay, and then we have L dot, I gotta do this. So what I have here is the L.sys file, and yes, you put the passwords in plain text in these. Obviously that's not a password I use anyplace else, but you get the idea. I've defined the PI and the login information here. I can call anytime on TTY01, 9600 baud. Serial port name takes the place of the phone number. And then what do I do here? If I hit enter and get a login prompt, if I don't get it in a few seconds, do it again until I get the login prompt. When I do, username's UUCP. By the way, I only do that twice. If it doesn't work on the second time, it bails. Anyway, if it does work, UUCP, and then anything ending with word and a colon, ship the password. So that's it. That's pretty much how it's configured. And on the other end, we have, actually let's do this. Let's grep UCP, let's see, password. So now the hardcore people are the only ones left. Okay, so now what we have here is I have UUCP set up as a user, and it has the password displayed on the screen over there that you all now know. And that's the shell. The shell is UUCICO, which is the program that actually does the send and receive file transfers for UUCP and UUX and the like. And the glue that binds this all together is a Getty instance that has been configured to listen on the TTY USB 0 port at a baud rate of 9600, and the terminal type is TRS-16. And believe it or not, there are a few terminal types in there that match TRS-80 computers. There's a couple of TRS-80 Model 2 ones, and there's a Model 16 one. There's also a XENIX one, but the TRS-16 one seems to have worked for this occasion. But that's kind of the overall configuration of this. So really, this Pi is just kind of an intermediary. So I don't call it a one-hop operation because it is two, but in terms of user operations, you can put a file in a Hadoop file system from a Model 16, or take data from a Hadoop file system with a Model 16 with one command. So until next time, thank you for watching.